antimicrobial agent as I have shown over there. After that, what is happening? They lyse the bacteria, and after that protoplasm is coming out. So now you see how we design our receptor. So we have used the combined approach. First is amino acid. We have seen in the extensively we have seen in the literature that amino acid are there in the peptides in the molecule who are successful to give the antimicrobial activity, and urea and thiourea derivatives are also there. Another thing is we have seen either people have combined as metal or metal oxide nanoparticle, and another thing is long chain should be there, long alkyl chain. If you can provide long alkyl chain, it's also quite good. So those type of things are there. So we combine to all these things together in a molecule, and after that, top on that, we self-assemble that molecule. And those self-assembled molecule we have investigated in the form of organogel, in the form of mycel, in the form of hydrogel, to see that which supramolecular assembly is giving better effect. So this was our design. You can see over there. More better we can show you. If we go by the organic synthesis, so we have started with tryptophan, and after that we combine with one of the pyridine carboxylic acid we have used, 2-pyridine carboxylic acid along with the methyl derivative of tryptophan. Methyl derivative we have taken in for such a way that after that we want to do the amide coupling by using some of the amide coupling reagent like HBTU, and that reagent are not working if you have the ester. So ester protection we have given over there, and this ester protection is better in the next step. After that we can treat it with the hydrogen hydrate, and we will create another amine over there. So pyridine we have taken. If I take the alkyl bromide, long chain alkyl bromide, if I do the alkylation over there, it will give me another set of receptors which we have commercialized recently. And after that, if you do the next reaction, we will get the urea derivative. So now you see the design. Tryptophan we have, peptide like structure we have, urea thiourea based receptor we have. So then one of the example, in this way you can synthesize the urea derivative. So we have taken one example. I can show you the results of that example. So first what we did, we made the hydrogel with this one. Why hydrogel? If those who are from the medical background, they know, maybe they are aware that if I have only one photosystem, it's not working. And if I have a group of photosystems, then it will work like anything in the photosynthesis. So same approach we have utilized over there. Let us see what happens if we have only that single organic molecule. What will happen if we have self-assembled receptor? What will happen if we decorate with silver nanoparticle or copper nanoparticle? And what will happen if we take the zero gel out of this organogel? So let us combine, I mean to say that it's not like that way you synthesize n number of compound, 15 compound bana lijiye, or after that you claim, okay, only one is working. No, it's fine. But on the other hand, you have another approach, means you make one compound and try to generate large number of supramolecular assemblies from that one compound. Let us see which type of merit we are getting out of it. So this is the organogel. When if we have this compound, and after that if you try to make the organogel, so you can see we will get the nice pattern of self-assembled structure. And after that, if you dry the sample, you will get the zero gel. Again in the zero gel, those supramolecular assemblies, they are not disturbed. It's not like that that way, okay, whenever we are having some water, only then it will give you a supramolecular assembly. No, it's not like that way. If you dry that water, again zero gel is generated, which is also having very good supramolecular interactions. And after that, if I interact with the silver or copper, then the shape of those organogels, this is being altered, and this is changed from a bundle shape to the either this is cluster type or this is the fiber type. So those type of shapes has been changed. And if I generate the zero gel out of these two, whatsoever organogel silver I have, organogel copper I have, if I generate the zero gel out of that, almost the similar type of shape or similar type of geometry I am getting. So means supramolecular interaction. Again, if I take only zero gel, if I take only organogel, if I take organogel with copper, organogel with silver, their supramolecular interaction are not disturbed if I remove the water out of the system. So is there any molecular level interaction? Yes, we have molecular level interaction. RP4 means we have a pure molecule. You can see carbonyl group is 1703, and whenever it is converted to the organogel, carbonyl group is shifted. It means there are some interaction in which this carbonyl group is participating. And again, when we interact with the silver, those carbonyl group are responsible to interact with silver or copper. So means some reasonable supramolecular interactions are there. And if you see the comparison of our compound, that is pure compound, organogel and organogel silver nanoparticle, clearly we can show that whenever we have compound, it was not acting as a very good, bacterial viability is quite high, means it's not giving you any antibacterial activity. But the molecule is converted to organogel, you can see the zone and you can see the reduction. Reduction is remarkable. So I mean to say, if you have any compound, it is not giving you the activity, convert it into some entity, some self-assembled structure, maybe you will get the better structure, or maybe you will get the better activity. And after that, if I put little bit of silver nanoparticle, again the activity is being approved. It's not only for E. coli we have checked with another bacteria, that is S. aureus, same pattern we have seen over there. And this is the zone of inhibition, as I have said earlier. The previous was for the silver nanoparticle, even for the copper nanoparticle, same trend we have seen with the copper nanoparticle. And if I have to compare between copper and the silver, then this this data is there in the form of zone inhibition. You can see in any case, copper is not better than silver, but it is reasonably good than that of only organogel in both the cases. And if we see the MIC, minimal inhibitory concentration, again that is from organogel to copper, organogel copper, it is giving the much better result for as far as MIC is concerned. Now let us see what will happen if I make the zero gel. Means if I compare a blank organogel, blank means only receptor, organogel, organogel copper, organogel silver in the form of zero gel and organogel, you can see organogel is little bit better than the zero gel. But with organogel, you have to make it stable. That is the one problem which you have to take into account. So in that way, we have seen over there that otherwise zero gel is also giving you some of the activity which is not expected otherwise from the silver or copper nanoparticle. Now another work we have started, that is chitosan based hydrogel. We have started with. Why chitosan? Because it's a biodegradable, biocompatible. People saying it's non-antigenic, non-toxic. So large number of these type of activity or large number of these type of properties are there in the chitosan. So we thought, instead of making the hydrogel with our molecule, what will happen if we take some application from or some activity from our molecule mixed with chitosan? Let us see is there any improvement. So accordingly, in the literature we have seen that there are large number of reports where people utilize their molecule along with chitosan, and after that they have seen some of the improvement. So again we have taken another molecule RP05, and in this molecule we have utilized along with the silver nanoparticle glutaraldehyde, that is a cross link, and we have generated some of the hydrogels, and those hydrogels shape you can see for hydrogel like that way. And after that some characterization, and after that we have seen that they are also having very good activity, antibacterial activity. Somehow data I don't have at the moment, recently we did in that way. So you can make the hydrogel if from the supramolecular assembly of pure molecule, if you are facing some problem, you can utilize chitosan type of molecule that also gives you a very good activity. Another type of molecule which in fact we popularize in the country, that is organic cation. If you see over there, those are the organic benzimidazolium, imidazolium. I have 4 or 5 patents which I commercialize on the basis of imidazolium and benzimidazolium based antibacterial agents. So long back we have synthesized this type of compound. Now there are some iron sulfur bacteria, and those bacteria need iron for their metabolism, and if we give that type of molecule which get rid of iron from the bacteria, then it will kill the bacteria. So this work was concerned with that type of activities. Another thing, like long chain, you can attach your molecule in that way, where we have let us see. So if we have silver, you can coat your molecule on the surface of silver, and after that you can create a self-cleaning surfaces, antimicrobial surfaces you can create. Long back we have done this work. Same type of material on one side you can attach with some entity like CNT you can put, and after that you can give organic cation, and long chain you can give, and you will expect a different type of activity out of this one. So very recently, this is the work. Previous work was like that way. For example, this is the surface. You apply that material, it will create a self-cleaning surface. So recently, we try to work for air purification. What we did, we have taken electrospin fiber and mixed with our compound, and after that we put in a system. There was one type of gadget, like this way gadget is there. Inside polluted air was there. Here our filter was there. From this side we are exposing all the air to the media, and after that we were checking that how much growth is coming to that media. And recently we published that it's an excellent antimicrobial or electrospin nanofiber, which are having very good antibacterial or antioxidant activity for air purification. So this is one part, that is how to achieve the antimicrobial activity. Another part is to get rid of AMR, means antimicrobial resistance. We have made very large number of membranes. If you pass the water from that membrane, after that the water will be purified as far as your bacteria is concerned. So recently we published one work on nitrate removal, and this membrane is further modified for the bacterial removal. So what was the synthesis? So as title of my presentation was organic cation. What are those organic cation? If you take benzimidazole, react with this, either you can take bromoacetic acid or ester of bromoacetic acid. So you will get that type of positive charge on the nitrogen. Now you see, if you see the whatsoever lysol you are using at your house, the active ingredient in lysol is BKC, benzyl choline chloride, or in most of the cases other are DDAC. You know? So means positively charged nitrogen is there, or quaternary ammonium salt is there. So that is acting as a antibacterial activity. So we try to give that type of antibacterial activity from that nitrogen, and after that this molecule get reacted with the hydrogen hydrate, and next reaction amine formation we generated this compound. So now let us see the activity of this compound. So when this compound was interacting with the iron oxide, after that we got some of the nanoparticle, iron oxide based nanoparticle. We actually, our first work was that there is a water sample. We try to suspend this material in the water sample, and after that, once we get the antimicrobial activity, we want to recover this material by using the magnet. This was the thought process for us to utilize this material where we are putting iron oxide as a material with which we can remove this entity from the water bodies. However, that was not as per our desire. Work was not progressing in that direction. So then we thought, let us put on the silica, and after that let us make a heterogeneous catalyst. Let us see that those activities. So basically the purpose was like that way. We suspend our material in the water body, and after its activity we recover our material with the magnet. That was the thought process, but somehow it gave a different type of property. So if we see the SEM of iron oxide, SEM of iron oxide, silica along with our molecule, so those type of SEMs shows that small particle are there, and after that when it was interacting with nitrate, there was a quenching in the quenching in the fluorescence intensity, which clearly show that nitrate is binding with this entity. Then we thought, let us change our direction from antimicrobial to nitrate removal. So for that we made the membrane, polyimide based membrane we made. You can see in those membranes that there are small perforation is there, so that if water is coming, it will pass through the membrane, but most of the things will interact with the membrane, so that nitrate will interact or nitrate will restrict on the membrane. And if I compare I and J, you can see in that region where I and J is there, and after interaction there are large amount of nitrate which is present on the membrane after utilization. There is another application with this membrane. If you shine light, if it's a pure membrane, and after that if you utilize it for long, after that you can see there was a change in the emission intensity. So means your membrane is now full with the nitrate or not, you will get to know only from light shining, only by shining the light. So removal you can see, and after that saturation factor we have calculated. If the water is containing less amount of nitrate, obviously the saturation factor is quite high. Otherwise, if you have high amount of nitrate, very easily you will polarize the membrane, and after that that membrane will not be of much use. So means in this membrane we have tried to combine or try to remove the nitrate exclusively, and after activity the color of that membrane was also changing. Another work we have recently did for the removal of antibiotic, means as I said, there are two applications. Either I have to generate new drugs which will give a antimicrobial activity better than the existing in the literature. Another way of addressing the things, means our antibiotics should not go to the environment, so that they will not create any type of antimicrobial resistance. So that work was inspired from that idea, that let us make some of the membrane which remove the antibiotic from the wastewater. So in that work what we did, we have taken organic nanoparticle, our material, and after that we made the metal complex, cobalt complex we made, and after that we made the membrane out of this, and eventually we find that it's removing the amoxicillin from the wastewater or from the household water. Receptor is very simple. If you see, just in 1 hour you can synthesize in your lab this receptor. Purposefully we have kept nitrogen, that amino group as free, because when we will synthesize the polyimide, basically it's a polysulfonate membrane over here, but another membrane which is being used in the commercial production from our group which was invented, there we utilize triacid diamine along with this receptor, so that covalently this compound will attach to the membrane. And if you see, upon successive addition of cobalt, there was a change in the absorption. It means cobalt is binding by utilizing two nitrogen. One is sp3 nitrogen, sp2 nitrogen, and the hydroxyl group. When the cobalt will bind over there, it will affect the ring current of azodide. So means after that there is a modulation or there is a change in the band gap. So that's why we are getting the shift. And if we see the particle size, you can see that that is coming less than 1 micron in size. So if it is less than 1 micron, very easily I can put it in the membrane having size more than 1 micron. So after that we try to interact with the amoxicillin. It was working like anything, it was working for the amoxicillin. So then I had found region to made antimicrobial or not antimicrobial membranes for the separation of antibiotics. So organic nanoparticles you can see like that way. after interacting with cobalt, it was agglomerating to some extent, but with the amoxicillin, it was agglomerating more. And then you can see the nice structure of our membrane. You can see we have controlled the porosity to an appreciable extent. Actually, we did lot of work in the membrane technology, and the day I got this SEM with one of my students, she was working for this one. So I was very happy then when she said that now we can control the thickness of membrane, we can also control the porosity. So nice pores are there, so that water can only percolate out of that one and other things will restrict over there. Now this is the lower membrane, C membrane, which was utilized before that amoxicillin, and after that when amoxicillin is combining, you can see that type of agglomerated structure are there, which we could see on the surface of the membrane. Again, our membrane is giving two results. One is they are purifying the amoxicillin. Another thing, there is a change in the color. You can see initially our membrane was like orange type of color, and if we continue to utilize for amoxicillin, after that when the whole membrane is covered with amoxicillin, it will convert to the, you can see the color will be light yellow type of color. So means if membrane is provided to you, it's a light yellow, it means it is already saturated with the amoxicillin. So these two applications we have shown with our membrane. Another approach is, third approach is also there. You can ask me that, okay, membrane is there, so whenever there is a high level of antibiotic amoxicillin, all the time it will polarize the membrane, all the time you have to buy new membrane. So but then we thought, let us make another strategy. Let us combine two things together. Like, I mean to say another way, let us say there is a 1 cup of tea containing some tea. So, and there are some mosquitoes there. So, what we have to do, we have to first pass through the sieve so that इसमें से पत्ती निकल जाए ना. After that you can whatsoever application you want from that tea you can do. So means if I combine the step 2 in that way, now before going that one, let me show you another thing why we are doing that strategy. Now you can see here, if in the water I have low concentration of nitrate, my membrane will last long for a longer time. If I am having high concentration, then my membrane will not last long to an appreciable time. Now my strategy is, let us put some of the chemical which first precipitate most of the amoxicillin, and after that whenever there is a small amount of that antibiotic, after that utilize the membrane, then our membrane will last long for longer time. So in that intention, we made some of the things. Let us do those type of things. Pre-concentration by self-assembly for aminoglycosides based antibiotics. So we have started with that antibiotics. So like one of my students, he said in that way. So I have put the same example over here. He said that let us say there are large number of animals. If one animal will try to go from this door, every animal can go outside. But if together they try to go outside, then it will be difficult for them to go out. So in the same way, what we did, if we have only antibiotic agent, and that antibiotic agent or antibiotic material interacting with our molecule, maybe this assembly become a water soluble. So if it will self-assemble in that way, definitely it will precipitate down. So that was the guideline principle in our mind at that time. So accordingly, I said, okay, let us make that type of compound where we put some of the chromophore, we put hydrophobic moiety, we put hydrogen bond donor sites, we put hydrogen bond acceptor site, and neomycin we have utilized. In the neomycin again we have hydrogen bond donor, hydrogen bond acceptor. If you want to know the synthesis, so we take N protected amino acid, and after that we react with the protected phenylalanine, and we got the product. TFA is utilized to break the Bock, otherwise it was a Bock protector. To break that Bock, we used the TFA, and after that we did this amine linkages synthesis, we got the final product. Now directly you will see if I show you over here, after that when we were interacting with that one, material was precipitating in that one, in that vial. Immediately it was precipitating, and after that if we redisperse in the buffer, you can redisperse in the buffer in that way. So what was happening, let us see in that way systematically. Otherwise the organic nanoparticle or self-assembled structure was having size less than 0.1 micron, and when the neomycin was interacting, it was showing small interaction, not very large interaction it was showing. However, maybe I missed one, yeah, this one. So those nanoparticle, and after that when it come in contact with the neomycin, after that we got those type of agglomerated structure. In that way we have shown diagrammatically over there. So, and if you put buffer solution, you can resuspend in the solution. So means agglomeration is there. So first you do the agglomeration of your material. Now the level of antibiotics will be lesser in that water sample. Now you can pass through from the membrane, and after that your membrane will also saved, and you can also achieve the target whatsoever you are designing. Another thing is, recently we have started with supramolecular solvent. It's a new thing, maybe it will be a new thing for some of the students. So means we have some of the solvent which act as a supramolecular, otherwise most of the time solvent are not interacting with your molecule. So in fact recently one of our review article, it published last week, where we have shown that eutectic solvent are acting as the supramolecular solvent. What are those supramolecular solvent? Basically these solvent are interacting with the drug, and after that they separate the drug out of the system. So how they are working, these supramolecular solvents? So in the supramolecular solvent, we make the micelle, and in that micelle we put our compound. You can see that compound with one pot synthesis we generated the compound which you can see over there. We put that compound. Purposefully we have put that compound because it has pyrene ring, it has, and in the drug molecule we also have highly lipophilic character we have, and that lipophilic character is interacting with this pyrene, and after that whenever there is a pi-pi interaction, which we can evaluate that pi-pi interaction from fluorescence spectroscopy, after that everything was precipitating out. So in that way it was precipitating out, so it was giving me the fact whatsoever I was expecting from that one, means some amount of AMT is separating from the solution. So that is another approach which we have utilized. So third approach which recently we utilized, that is organogels for the detection and decontamination of thiabendazole, those type of drug molecule. Again here we are utilizing, basically we had a very small molecule. In the previous example our molecule was quite large and it was expensive to synthesize. Here we have taken small molecule. By using terbium we convert it into the supramolecular assembly. In that way we made the gel, and you can see in that gel we remain successful to show that it remain in the form of fiber. Metallogel is formed in the form of fiber, and those fiber when they were interacting with the, now terbium is there, so that's why that type of fluorescence you can see out of that terbium, and upon interaction there was a change in the fluorescence intensity. So mechanism, you know why we are getting this type of pattern. Basically we are getting the phosphorescence with the terbium. Last approach, peptidomimetic based system for the removal of pharmaceutical ingredient from the ETP. Basically we had one project from Baddi from the ETP, CETP, where we were working for the removal of